We're doing an example today with Ryan's American Girl doll. We're going to have my three brothers, that's right, I have three of them. They're going to be arguing over the American Girl doll. We're going to have the force of Ken is going to be equal to 17 newtons east. Now notice the subtlety here. This is not northeast, but rather 17 newtons east. We're going to have the force of Jim. He's also an older brother, not the oldest. He's going to be 23 newtons south, and my little brother, the force of Chris, is going to be equal to 26 newtons, although he's not littler than me anymore, at an angle of 34 degrees west of north. So our goal here is to figure out the net force from all three of these forces. They're going to be fighting over the American Girl doll. What is the net force from my three brothers here fighting over the American Girl doll? Considering we are dealing with forces, before we do anything else, what should we do, Nick? Draw a picture. Draw a picture? Yes, a specific type of picture. I agree with that. Who tell me what specific type? David? A free body diagram. So we're going to approximate Elizabeth Cole here. There she is. She's got hair. By the way, you have to get a specific brush to use to brush their hair. We have one. It came with a DVD on how to do different braiding. Oh boy. Okay, anyway. So we have our force of Ken, the force of Jim, and we have the force of Chris, which is at an angle of theta of 34 degrees west of north. Now that we have drawn our free body diagram, we are going to figure out the net force. Before we can do so, who can tell me what we should do? What we have to do? Meredith.
Split Chris up into south, or north and west.
Right, I'm looking for a specific term. You're correct, but what is the specific phrase we need to use? Andy?
Split it into its components.
What's it? Just to make sure.
The triangle.
No, I'm looking for the it here. What are we breaking into its components, Wheatley?
The vector force of Chris.
The vector force, the force which is a vector of Chris. Notice the force of Ken is in the x direction, the force of Jim is in the y direction. The force of Chris is neither in the x or y direction directly, so we need to break that force into its components. Will you look at that? We get to review something. The force of Chris, we're breaking into components. We're going to have the force of Chris in the y direction. We're going to have the force of Chris in the x direction. We have our theta, which is 34 degrees west of north. Please help us break this force into its components, Christina.
Force theta equals.
I'm sorry, I missed that. But we're trying to figure out the components of the force of Chris. So the force of Chris in the y, force of Chris in the x. How are we going to do that?
Force of Chris where?
She's not seeing it. That's okay. Help her out. Leah.
Delta equals. Do you want to play what everything equals? Right?
Sure, let's try this. This is interesting.
No.
Go ahead. I don't know what you're doing, but that's fine.
Never mind.
It's more fun when we do stuff I have no idea what it is.
No, it's okay.
Oh. Sam.
Okay, so we're gonna have to figure out what the y direction is for the force of Chris in the y direction.
Yes, we are. I agree.
So
Is fine.
we're going to use cosine.
Oh, or
Theta equals adjacent over hypotenuse,
what is adjacent?
which equals force of Chris in y over force of Chris.
So we're just figuring out the size of the triangle here. So all we're going to use is SOHCAHTOA. Cosine theta equals adjacent over hypotenuse, the force of Chris in the y direction divided by the force of Chris. Therefore, the force of Chris in the y direction is equal to the force of Chris times the cosine of theta, where the force of Chris was, I believe, 26 newtons times the cosine of 34 degrees. So we get the force of Chris in the y direction.
21.555 newtons.
We do the same thing with the sine. Sine of theta equals opposite over hypotenuse. Opposite is the force of Chris in the x direction divided by the force of Chris. Therefore, we get that the force of Chris in the x direction equals the force of Chris times the sine of theta, or 26 times the sine of 34 degrees.
14.5390.
Newtons. Great. Now that we've broken the force into its components, we're going to redraw our free body diagram. We still have our American Girl doll. She's still happy and she still has hair. We still have the force of Ken and the force of Jim. Those are the same, but now we have the force of Chris in the y direction and the force of Chris in the x direction. Rather than having the single force, we now have the components of the force of Chris. We're going to figure out the net force here, so let's start with the net force in the x direction. Looking at our free body diagram, what forces are acting in the x direction, and please tell me whether they are positive or negative. Brittany.
Okay, so do I tell you like all of them? Or force of Chris?
Just the ones in the x direction.
That's negative.
What's negative?
Force of Chris in the x direction.
Great.
And then the force of Chris in the y direction.
But
Positive.
that's in the y direction. Remember, only some of the forces in the x direction.
So force of Ken is positive.
Correct. So the only ones in the x direction are the force of Ken and the force of Chris in the x direction. Our goal is to figure out the net force in the x direction, so the negative force. So negative 14.539 plus the force of Ken was 17. What is the net force in the x direction, please? .461? Yes, 2.461? Okay. We can figure out also the net force in the y direction. That is equal to, please look at the free body diagram, Lily, give me the forces and whether they're positive or negative.
Negative, the force of Jim, and then the force of Chris in the y direction is positive.
Great. The force of Jim was 23 newtons, so negative 23, plus the force of Chris in the y direction was 21.555. The net force in the y direction. I'm sorry, I missed that. Negative
1.455.
4, 5, 4,
4.
Just wondering about that. 445, right?
Yeah.
Okay. And so now we have, instead of these four forces, we actually have it now just the net force in the x direction, net force in the y direction. Again, the doll, the hair, the smiling face. We have the net force in the x direction, which is this way, and the net force in the y direction, which is this way, the net force in the y direction. So our goal is to figure out the net force. Now notice this is how we usually draw it at this point, but I'm going to draw the arrow here, the dotted arrow, to illustrate this is the net force that we're trying to find. So I could draw this with the net force in the x direction, the net force in the y direction, and we can figure out the net force. Notice how that is essentially the same thing. So how do I figure out the net force then, Michelle? A squared plus b squared equals c squared. What are a, b, and c?
B squared is the force of the x direction, up squared, plus in the y direction squared, the force equals the total force.
I always write down what people tell me to write down, even if they forget things. Because sometimes forgetting things helps you to remember things. Josh? You gotta have the same as this is the net force. You just said the force in the y direction, the force in the x direction. These are the net forces in the x direction, the net force in the y direction. Those squibbles are very important. So the net force is equal to the square root of the net force in the x direction squared plus the net force in the y direction squared. Net force in the x direction was 2.461 squared plus net force in the y direction, negative 1.445, which we're also going to square the square root of. The net force then is equal to
1.992108431.
So, hold up. Who can tell me why that can't be the answer? Meredith?
Because if you pick 2 squared, then be 4, and that might just be
The hypotenuse can't be shorter than any of the sides, right? My guess is you forgot the negative, that we have the negative needs to go under the square, so it actually ends up being a positive. Knickerbocker?
I got 3.0104.
Independent confirmation of this number. All right, what other numbers might we have? We'll do it by committee here. 1.99 something, we'll go 3.01.
2.853847.
We got any other ones, or does anyone want to confirm any one of them?
I got a miss.
Third one.
We got the third one. If you got 2.8537, please raise your hand. It is a democracy. We can do math by democracy. That sounds good. Okay, we got the 2.8537. Congratulations, people. Sum of the forces equals, with sig figs, 2.9. What are the dimensions on that, Maria? Newtons. So the net force for my 3 brothers, Ken, Jim, and Chris, fighting over the American Girl doll is 2.9 newtons. I'm happy. It makes me happy to see so many hands raised at this moment. Brittany?
You need a direction.
What is it about my statement that the net force equals 2.9 newtons that says we need a direction? I agree with that. Wheatley?
Oh, the net force is a vector.
Force is a vector, therefore it needs both magnitude and direction. We need a direction on here. Notice we could figure out either one of the 2 angles. We could figure out this angle, or we could draw it this way, and we could do, oops, drawing it the same way isn't helpful. We could draw it this way, and we could figure out the net force with the net force in the y direction and the net force in the x direction, where theta 1 and theta 2 will add up to 90 degrees. They would be complementary angles. Please tell me which angle you are figuring out and how to do so. Mitchell.
Sine theta 2 equals opposite over
What is opposite theta 2?
the sum of the force in the x direction
Over.
over the sum of the force.
Great. So theta 2 then is equal to the inverse sine of the net force in the x direction divided by the net force. Inverse sine of net force in the x direction was the 2.461 divided by the net force, which I'm hoping was 2.8537. Theta 2 is equal to hopefully we don't have to vote on this one. Just so you know, this is where I give the happy clicking of the calculators. 59.5859. Looking for independent confirmation.
59.5859.
That's a yes. I need one. I need more than that. Clearly, from this group, I need at least 3.
Yes.
Okay, there we go. We got 3. So this is a fun one because this works out to be 60 degrees. So notice how we have to do this. This says at an angle, because we need 60 degrees with 2 sig figs. It's 6.0 times 10 to the first degrees. And you wouldn't want that 1 and the degree sign combining to something that looked like a 10, right? So 60 degrees what? This one right here. 60 degrees what, Andy?
South of east.
South.
No. East of south.
People agree with east of south. 60 degrees east of south? Yes?